Hello and welcome. I'm really excited that you're here to learn more about the Cloud Digital Leader certification, brand new certification from Google Cloud. Let's go ahead and talk about what the course is going to cover and also learn more about your instructor. So as far as the course is concerned, it's broken down into different sections. The first section is the course overview. In this section, we'll go through the course and instructor overview. We'll talk about the pre-requirements for the course. We'll also talk about the GCP certification portfolio itself, and then get into the exam objectives, which will be very important to understand, of course, before taking the exam. Now, as far as the course itself and the instructor, let's go ahead and get into that first. The course itself is broken down into the sections. Basically, we have the course intro, we have the general cloud knowledge section, we have the general GCP knowledge section, and then we'll talk about products and services, and then we'll close out the course. As far as the course itself, what we'll learn is going to be mainly focused on cloud computing fundamentals. We'll understand what the cloud is, why it's important, and of course really focus on what we want to know for this exam. We'll then talk about why enterprises choose GCP. We'll then get into the major Google Cloud services that we'll want to know for the exam. It is important that we understand the billing and the pricing models for Google Cloud. We'll definitely want to choose the right GCP services. On the exam, we'll need to, of course, select the proper service for the proper use case effectively. We'll then want to talk about, of course, the certification objectives in more detail. And the goal of the course, of course, is to really provide you everything that you need to know to pass the exam the first time. Now, as far as the reasons you're here, it could be for any number of reasons, but generally you're probably here to learn more about cloud computing. You probably want to learn more about Google Cloud. And most importantly, you probably do want to get certified. So we're here to help you pass the exam. As far as the learning reinforcements provided, this is really, again, focused on the exam. And we'll go through some demos and we'll go through some lab examples to provide you insight into some of the services. We'll go into whiteboard discussions and sort of walk you through visually how we could architect certain services and solutions. Provide you documentation links. We'll also provide you more than enough practice questions to prepare you for the exam. Then I'll also provide you access to our community sites that we have available. Before we get started on the next lesson, let's go ahead and do a quick intro to your instructor. My name is Joseph Holbrook, and I'm the CLO of TechCommanders in Jacksonville, Florida. I'm highly certified in Google Cloud as well as blockchain and AWS as well. I've been in the IT industry for 25 plus years, have flown around the world providing pre-sales and post-sales services. But with that said, I'm also a published author, also a prior U.S. Navy veteran as well. We have a lot to learn here, so let's go ahead and get started on the next lesson. Course pre-requirements. Let's talk about what we need to help you get the most out of this certification course. So basically, this course is really a 101 course. It's a fundamentals course. There isn't any technical pre-requirements. So as far as experience, same there, no real experience requirements. It would be advisable, of course, that you followed along as much as you could, practice any of the recommended exercises that we'll go through to help you, again, get enabled. So with that said, mainly the pre-requirements is if you want to follow along, you go ahead and use the GCP free tier to do that. And also, too, please certainly review all the practice questions and quizzes that you'll have, and that will really, again, help you pass the exam. Let's go ahead and move on to the next lesson. Exam overview. Let's talk about where the exam fits in and understand more about the exam at a high level. Now, the exam itself is effectively Google's introductory, foundational, beginner certification That's Google's view. I've personally taken the AWS Practitioner and the Azure introductory certs as well, and this one here is somewhat harder than both of those on the same level when you compare them, I think. What I mean is, it seemed like I was taking a cloud architect exam, not like a 101 certification, to be fair and honest. So, throughout the course, I'm going to go through everything you need to be successful on the exam. If you've taken the AWS Cloud Practitioner exam, from a comparison perspective, this is about 40 to 50% harder because of the way Google asks the questions. They're scenario based. A lot of them are going to be similar to Cloud Architect certification, so be aware of that. Okay, so the certification is considered basically foundational, not associate, not professional. So with that said, that's where it fits in. Now, the exam itself is going to test you on Google Cloud computing knowledge, also general cloud knowledge, and cloud products and services. Now, a lot of the questions will be scenario-based, where you're going to get a paragraph, I guess is the way to look at it. Excuse me. And you'll need to be able to read the scenario and figure out, how do I migrate from here to here? Or you'll need to understand, is this a good fit to go from on-prem to the cloud? Some of the answers, to be honest, I actually thought they didn't really make sense to go to the cloud, when you looked at it. So it just seemed like the question and the answers didn't really sync up. And this is something I commented on. I took the beta exam, so just be aware of that. There wasn't a lot of general cloud knowledge, like what a platform as a service is, or what are the basically characteristics of the cloud, or anything like that. Very few. Most of them were on Google Cloud services, and again, how do you migrate from point A to point B? Okay, so what is this digital leader? Basically, they expect you to articulate the capabilities of Google Cloud and how they benefit organizations. So you'll need to be able to understand, well, if I use Kubernetes engine on Google Cloud, that means that I can extend my organizational Kubernetes deployment, assuming everything is, a cloud fit, basically, to Google Cloud, and then I can extend it back. Or I can migrate my VMs with this service, let's say, to Compute Engine. So it's all about understanding where things fit in. Also, too, you'll need to understand specific business use cases. For example, why companies go to the cloud. You'll need to look at the paragraphs or some of the smaller, questions, and see where that really fits in, basically. Lastly, it says it's job agnostic, and you don't need hands-on experience. So I agree with that. You don't need to, spin up a Kubernetes deployment or anything. It's more from an architecture point of view that you'll really want to focus on. That's all that I had for this lesson. Let's move on to the next lesson. In this lesson, let's talk about the objectives of the exam, and that way we can get a clear understanding of the subjects we're going to need to study for and to be aware of course, for the exam. Let's go over to the objectives website. So I'm over here at the certification webpage. Now, to get to where the objectives are, what we want to do is scroll down over here to understand what's on the exam. Now, Google calls this the exam guide. Anyone that has developed exams would know that these are the objectives. Google just calls them basically the exam guide. So we go over here to the exam guide, and this will let you know the specific subjects that you're going to be tested on. The first is general cloud knowledge. Everything from the shared responsibility model to understanding the characteristics of cloud computing, service models, procurement models, CapEx, OpEx, return on investment, TCO, pretty much. And then we get into the Google Cloud knowledge. So this is where we want to understand like the hierarchy, like projects and organizations and folders. And I won't read all this to you. It's pretty much there for you to take a look at. But the exam will cover pretty much everything here, no question about it. And my course that you're going through now will cover pretty much more than enough. And with that said, we're going to go into, again, the objectives in detail. So I want to spend a lot of time on this. And then the products and services you'll be tested on, everything from compute engine to basically Kubernetes engine, Cloud Run, Cloud Functions, and then some of the data services you'll want to understand. Also, too, machine learning and AI. This can be a little tricky for folks that are new. And then this is where, again, the use cases for cloud architecture. This is, again, what I was talking about. This seemed to be pretty heavily, this section right here. Design this, differentiate, describe. It just seemed, again, the test was really heavy in this area here. But that was just my experience, of course. So with that said, this is the exam guide, the objectives, basically what you'll be tested on. Let's move on to the next lesson. Section 2, General Cloud Knowledge. This section is, of course, going to focus on the basics. Just from a non-vendor perspective, we want to know what cloud computing is, why it's so important, what are service models, deployment models, what's chargeback, what is OpEx and CapEx, and why do companies go to the cloud? What are the business enablers? Then I'll also follow up, and this is true for every section of the course, with some test tips, a section summary, and some review questions. We have a lot to cover. Let's go ahead and get started. Domain objectives. Let's go ahead and find out what exam objectives will be covered in this section. So for this specific section, we're looking at ensuring that we understand basic cloud technologies. We'll then move on and talk about the service models available, and then we'll talk about procurement financial concepts. That'll be mainly CapEx, return on investment, etc. Let's go ahead and get started with the first lesson. What is cloud computing? Let's talk about what the cloud is. First, let's just talk about historically where it came from, why it's so important. But basically, we want to think, of course, first, the cloud's been around a while. It's been around, effectively since about 2006 or so. And that really started again with Amazon releasing effectively Amazon S3 right around 2007 or 8 or so. There was, of course, some other precursors to that, but that was the first major leap. And then when we think about the cloud, we can also think about software as a service as well, which really started pretty much with Salesforce in the early 2000s, late 90s or so. But basically, when we're focused on cloud computing in the world of the cloud platform providers such as Google, AWS, and Microsoft, their history is a little bit newer than Salesforce. So basically, this came about based on the fact that the federal government, first of all, and that's in the United States, needed a way to really standardize, basically what they're looking for, but also what's being requested, and try to define a lot of standards and best practices. And that's where NIST came in. So NIST is a entity under the Department of Commerce here in the United States. So this is their definition. So let's talk about the official definition, and then we'll get into basically other definitions. I'll also talk about what Google, sort of considers cloud computing as well. So first we want to define it. So what exactly is this cloud? So basically cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable compute resources. And it can be rapidly provisioned, released with minimal management, and be simple enough as well so that the provider doesn't have to do a lot of work, so less interaction. Basically, there's 5 essential characteristics, 3 service models, and 4 deployment models. We'll talk about each of those in the upcoming lessons. So again, this is where you want to go first, just to take a quick look to understand more about the defining factors around what is cloud with NIST. So from a definition standpoint, we could look at this a little bit more simpler. Basically, cloud computing is the on-demand delivery of cloud resources effectively. And that could be data, it could be compute, applications, etc. But basically, we're going to access these services via the internet, and we're going to have pay-as-you-go pricing. So basically, the main key here is to realize that cloud computing is the on-demand delivery of basically resources. Now, one of the things that typically comes up is, is cloud and virtualization the same thing? So it's important to realize that cloud and virtualization are really two different things. However, they're complementary. So without virtualization, though, it's really hard for cloud computing to work from an economics perspective. Now, if providers had to take, for example, a server and have it dedicated to one application or one user, then it would be hard for them to be able to provide a low cost without having to charge you for the whole cost of the resource. And with cloud computing, it allows us to use virtualization and split up the cost between 10, 20, 200 users, whatever that ratio may be for that resource. So basically, we have to be able to separate resources from basically their physical location. That is done through virtualization. Now, without virtualization, the cloud is going to be very difficult to manage, and honestly, economically, it would not be profitable. Now, when it comes to cloud computing, this is again a model that the ownership of resources is going to really be with the service provider, and then you as the user will effectively be using these resources and paying effectively almost like a lease. And then you'll be, of course, billed for what you used. Now, historically, we just want to be aware of that with virtualization. This came about early on before the cloud. So with virtualization, this really started with IBM, and then really took off when VMware came out in the late 90s. So again, with virtualization, this was really used in mainframe, and then we saw virtualization go to the x86 community as well. Now, with cloud computing, we have, again, basically what's called the essential characteristics. So basically, that's going to be what should the cloud provide? And basically, we want to be aware, too, that these characteristics should be pretty similar between cloud providers. In other words, we should be able to log in and spin up resources and then spin them down when we want. We shouldn't have to send an email to someone and say, hey, I need a resource spun up. I need this VM spun up for me. That's not virtualization really in the sense of, having it manually done, right? And it's not cloud either. So with that said, we want to be aware that there's characteristics. We'll talk about the characteristics in the upcoming lesson. Then we'll also talk about the service models and the deployment models. So we could think of the service models basically as sort of a way of understanding how we want to provision our resources, and then deployment models, again, similar in that sense, but a lot of it comes down to, again, the difference between both of these is going to be how it's deployed and then how much does the provider do in a lot of cases. So we'll talk more about each of these in the next few lessons. Now, it is important to understand why cloud companies are successful. The reason they're successful is because companies have a lot of challenges. Some of those challenges is, again, can they get the resources on time? Can they provision resources and do it efficiently? So companies that use cloud computing leverage these resources basically from a provider such as Google. Now, the reason companies want to leverage resources from another company is because they provide value to the organization. So if you're a company, you don't have to go out and buy, for example, brand new servers and brand new data warehouses when you could use the same resource on a cloud provider and basically only spend a fraction of that in costs. And also, too, not worrying about the infrastructure, getting up electricity, permits pulled, having the real estate for a server farm, whatever it is. But basically, we want to pay for what we use and not what we don't need. And that's the benefit of the cloud. So what does Google Cloud really look at the cloud as? Basically, their definition is more simplistic and straightforward. Basically, Google looks at it as a way for you as an enterprise to use a software system that is going to deploy functions and applications on an as-needed automated basis. So that's really simplistically, again, how Google looks at it. Now, as far as some test tips, again, we're just getting started, just simple things to consider and remember for preparing for this exam. The first one is cloud computing is an on-demand delivery of resources. The second thing, cloud computing and virtualization are complementary. They're not the same. It is important to realize that really without virtualization, cloud probably wouldn't be what it is. Lastly, in cloud computing, we're going to pay only for the resources that we need. That's all that I had for this lesson. Let's move on. Essential cloud characteristics. Now, when it comes to the cloud characteristics, specifically from NIST, it is so important that we know these for the exam. So let's talk about these. So first of all, what are they? Why are they so important? Now, NIST defined 5 essential cloud characteristics as follows: on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. Those are the 5 characteristics. So let's go ahead and talk about each of these. Now, on-demand self-service, so what I'm going to do is I'm going to go through the official sort of definitions from NIST. Then I'm going to break it down for you in a table in much simpler terms. So basically, on-demand self-service, according to NIST, is basically where a consumer can provision capabilities such as server, network storage, etc., without having to directly ask the provider. Basically, it's on-demand self-service. They provision. The provider basically doesn't do anything. From a manual perspective, it's all automatically provisioned. Now, broad network access basically sums up like this. It basically is allowing you as a customer to access the resource anywhere that you can with an internet connection. Resource pooling is basically really based on the fact that we can have a multi-tenant environment as a provider, for example. So, for example, if I'm able to put together a pool of resources and provision those resources to hundreds of customers, I know that I could provision those resources and not have to worry about, for example, running out of resources if I keep my thresholds appropriate generally. But basically, the provider is going to provide the consumer resources, and because of that, they're using a multi-tenant environment with virtualization. This really allows the ability for a consumer to get resources at a much cheaper cost than what they would if they had to go out and purchase this configuration, for example, themselves. So really important facet of the cloud. Now, rapid elasticity is basically allowing you as a consumer to scale up and then scale down as needed. Now, if you think about it, the ability to add more storage on the fly or change your compute template can be very beneficial. And because of that, you have the ability as a consumer to scale up and scale down as needed. Now, measured service. This is pretty straightforward. Basically, we want to be able to measure what you're using as a consumer. And if you're the consumer, you want to understand what you're using and what you're paying for. So being able to monitor and understanding what your bill is very, very important. So again, from a terminology perspective, this is basically NIST terminology. So now let's go ahead and break this down a little bit simpler. So when we look at on-demand self-service, the best way to sum this up is that the resources are available for you as a consumer to use anytime. Broad network access is basically just stating that we could access the resources from anywhere we want, or any device we want. So basically I could access it on an iPad or a Linux box somewhere in a data center. It doesn't matter. As long as I have an internet connection, I could go ahead and access that resource. Now, resource pooling is basically, again, taking resources and optimizing those resources based on, of course, virtualization in multi-tenant environments to where that resource is pooled, and basically it can optimize the quality of the service and also the cost of the service really to the consumer. Then when it comes to rapid elasticity, this just basically allows you as a consumer to scale up and scale down as you need without any real provider-based interference or assistance for that matter. And then measured service. So basically this just allows you as a consumer to make sure that you're understanding what you're paying for. Pretty much that sums that up. So again, the cloud is not that complex, right? It's pretty straightforward when you look at it from this table, right? Basically, I'm going to be able to access the resources anywhere I want. I'm going to be able to scale up and down as I need. I'm getting a great cost and a great benefit because there's resource pooling that's managed by the provider. And then, it's there when I need it, but also I can pay for what I need and understand what I'm paying for. So let's go ahead and take some test tips here, talk about them. All right, so the first test tip is, once again, right, cloud computing is on demand, right? Very simple concept. Rapid elasticity allows for scaling based on consumer demand. Multi-tenant models and virtualization allow for resource pooling. Now, if it wasn't for the ability of virtualization and the ability to take resources and combine them together with virtualization, then the cloud wouldn't really be working the way it works. It just wouldn't work. So once again, pooling is really the key to the economics of the cloud in reality. So once again, just get to know the 5 characteristics. Just use the table that I gave you there. Pretty straightforward. You'll get it pretty quickly, and that'll be the level of questions you'll get pretty much on the exam around the subject. So let's go ahead and move on to the next lesson. Cloud service models. Let's go ahead and talk about what the service models are and why they're so important in the world of cloud. So generally, according to NIST, they broke down the service models to basically 3 specific models. The first is software as a service, the second is platform as a service, and the third is infrastructure as a service. So let's talk about each of these. So when it comes to infrastructure as a service, this is basically going to be the very basic cloud capabilities. And what I mean by that is this is really where you're able to deploy a virtual machine on AWS or on Google Cloud, let's say. So that gives you as the consumer the ability to deploy basically a virtual machine and add all the networking and storage and other capabilities and deploy on a cloud platform. Basically, it provides the highest level of flexibility and management control over your infrastructure in the cloud. So examples of this would be Google Cloud Platform, Compute Engine, and then AWS EC2. Now, platform as a service is one of my favorites in the sense of the ability for development teams to be able to use a platform and not have to worry about the infrastructure underlying the platform. For example, when it comes to App Engine or Elastic Beanstalk, developers can just roll out their runtime environment that they want to use and then develop on top of that. That really just gives them the flexibility to not worry about the infrastructure. So platform as a service removes the need for your organization to manage, to have to manage basically the underlying infrastructure. So you don't have to worry about the virtual machines. You have to worry about setting up a lot of the networking or other services. It's pretty much all part of the managed service. So platform as a service is typically in the world of cloud considered to be a managed service as well. We'll talk more about that. Now, platform as a service is the second highest level of flexibility. Basically, it allows the developers to at least pick and choose a runtime environment and then load their application that they want to develop on top of that specific platform. And then we have software as a service. This is going to be a complete product typically, and the user is just going to typically add users or add data basically. There's no changes made to the underlying infrastructure or the platform or the software itself. Basically, you just use the software and not worry about the infrastructure. Now, this provides the lowest level of flexibility. Examples of this would be Google G Suite and then Microsoft Office 365. Another popular SaaS would, of course, be Salesforce is another good example. Now, when we understand the service models, it's important to know really the difference between these. Now, going into the exam, I like to bring up basically a couple examples and comparisons to help make sure that you understand. Now, when it comes to the different service models, a lot of that is going to come around the functionality and the services offered. There is a shared responsibility model as well. This is something the providers will be pretty clear on as well. And it's similar to what's called the pizza model. So if you haven't heard of the pizza model, this is basically called pizza as a service. And this is basically a service that was sort of made up just as a comparison. Graphics is basically compliments of Paul Harrison. It was pretty much came from him, I believe. But basically, it's a great example of basically how to compare the service models to something that everybody would know, right? So basically, when we think of like the traditional IT model, so over here we have the traditional model, over here we have the pizza as a service. So when we compare traditional IT to basically a pizza service, this is where we're going to develop everything ourselves. We're going to make it totally, everything from the dough and above. Then when we get to infrastructure as a service, basically the provider over here is providing you as a customer everything basically above pretty much the operating system level or the virtualization level basically. Now, generally this is pretty much right here. You're going to deploy your operating system, which would be Linux or Windows, let's say, and basically then you load everything else, you configure everything else as you want. So that's infrastructure as a service. Now over at the pizza model, we have basically an example of you going out effectively, basically getting the dough, putting it together yourself. It's called like a take and bake pretty much. And, that would be similar, I think, to a chain called Papa Murphy's is a common one in the U.S. And again, fairly straightforward there. Now, what about platform as a service? This is pretty similar to basically pizza delivered. This would be you calling up a pizza company and they deliver the pizza to you. You just have to throw it on a table and cut it up, or if it's not already cut, right? That's all you do. And then we have software as a service. This is basically where you go to the restaurant, everything's done for you, pretty much it's good to go. So this is really, again, how we would compare the different service models and comparing it to something that a lot of people would be familiar with. So with that said, we want to go into the exam understanding that infrastructure as a service is going to give us the most flexibility, platform as a service will be second, and then software as a service will be, of course, last. Now, with that said, we could see here, though, as we grow from basically less to do and more for the provider to perform, let's say, as a consumer, then we're basically, again, going to have less flexibility, but we're going to have more responsibility on the provider over here. So with that said, that's just a short comparison. Hopefully it helps. Okay, and then when it comes to sort of simply putting together, basically, the three service models here. Infrastructure as a service is really using data center resources like computer, network, and storage resources. Platform as a service is really going to be more databases, web services, and middleware applications generally. And then infrastructure as a service is pretty much going to be mainly focused on customer apps. This is really where typically you as a customer deploy your VMs, load your operating systems, and load your applications on top of that. This is where mainly you're going to have that customized enterprise app typically. And then as far as the test tips, there's 3 service models, and we haven't talked about deployment models yet, but we will. There's 4 deployment models. Now, generally, and you'll see where this comes into play, generally service models and deployment models are going to be confused to a lot of people early on. And the goal is, again, you'll want to, understand service models versus deployment models. So there's only 3 service models, and then there's 4 deployment models. So we'll talk about those next. Now, SaaS provides the lowest level of flexibility, while infrastructure as a service provides the highest level of flexibility. With that said, let's move on to the next lesson. Cloud deployment models. Let's talk about the 4 NIST cloud deployment models. Now, in the world of NIST, there's 4 specific deployment models, and they are private, hybrid, community, and public. So let's talk about these. So public is perhaps the most straightforward one to understand because of the fact that this is basically going to be a cloud service such as AWS, Google Cloud, or Azure, for example. In other words, a cloud platform is open to the public to use. Anyone can use it. Any company can use it pretty much. And as long as you have a credit card to sign up, you're good to go. Basically, we can spin up resources in the public cloud on demand without any issues and access the service from anywhere. Pretty straightforward from that perspective. So public clouds are going to be AWS, GCP, Azure, it could be Rackspace, could also be any other service provider like one of the bigger ones like overseas would be Alibaba perhaps. But whatever service provider you're thinking of, that's a public cloud. And then if we think about SaaS solutions like Salesforce, that would be a public cloud as well. Now, hybrid is going to be where we combine typically a public cloud with typically a private cloud component. Could also be community cloud as well. But basically, a hybrid cloud is going to be 2 or more distinct cloud infrastructures. So basically public and private, for example. Now, a private component or private deployment is going to be basically where the enterprise that is sponsoring the private cloud is going to manage the infrastructure, pay you the full cost, and basically take responsibility. Now, generally, organizations that go with the private cloud are going to want to have some benefits as a result of that. Typically, companies go with the private cloud because they have the control over the infrastructure. They can meet compliance requirements typically a lot easier. Security is going to be in their control, and then compliance can also be met as well. But with that said, and then also too, performance is, again, that's important to talk about too, because some customers may not get the performance that they need in the public cloud, so they may need to host some of the resources locally. And then we have community. Now, community is an interesting type of cloud. This is where we're going to have typically a consortium is a way to look at it, where that consortium or group of entities is going to work together and share resources. So basically, this is open to members of a community. Examples of that could be everything from the military to nonprofits to educational institutions, etc. So how do you sum up basically these 4 deployment models? Basically, the private cloud is on-premise typically. Now, one thing to point out, and I typically get a question like this sometimes, is, well, AWS or Google, they have a virtual private cloud, so would that be private? Well, in reality, a private cloud from a definition perspective has to have fully segmented and fully autonomous, basically hardware and software. In the public cloud, that's not true. You have basically a sandbox. That's basically the extent. So theoretically, an Amazon or Google or Azure, their private clouds would not be actually what NIST means. So just be aware of that. So basically, if it's hosted on-prem on the company's enterprise, then, enterprise equipment, let's say, then that would be a private cloud. Now, hybrid is when we combine two or more of these models. So typically, a hybrid is going to be a public and a private cloud, or it could be a public cloud and a community cloud as well. And again, it could be two or more of these models. Now, community, again, is going to be shared by different organizations that are like-minded, really. And then public cloud, basically anyone, can use this service, and it's open to everyone. And you can run pretty much all your services in the public cloud nowadays. The reality is whether it's big data, machine learning, just storage, whatever you're trying to accomplish, it can be done in the public cloud. Now let's talk about some test tips. Now there's 3 service models and 4 deployment models. Remember we talked about service models in the previous lesson. So a hybrid model is used basically for bringing together 2 or more deployment models. Typically it's private, public, as sort of the hybrid approach that's used. Now, private cloud is used for enterprises that require high security, compliance, and even better performance. That's all that I had for this lesson. Let's move on. Multi-tenancy. Now, let's talk about multi-tenancy and understand a little bit more about it. I know that we talked briefly about it during the 5 characteristics, but there's a few other things I want to touch on to make sure that we understand. So multi-tenancy is resource pooling effectively. This is what really enables the cloud to be the cloud. And with this in virtualization, we really wouldn't have a cloud because of the fact that we would be effectively deploying services, for one party all at one time. So with multi-tenancy virtualization, we're able to have multiple tenants on the cloud platform. So as a provider, this is a huge benefit because it provides the provider, of course, benefits such as being able to purchase all kinds of equipment and share it out and gain revenue from that. But as a consumer, it provides benefits in the sense that you can use resources at a really reduced cost of what it would typically cost to use a data service, for example, like BigQuery, or use a cloud storage service like Cloud Storage or Cloud SQL. So with that said, Google Cloud is a public cloud and it uses multi-tenancy. Now in the diagram here, and this is from VMware, basically we have different customers. And basically you can see here that they're sharing virtual machine instances in a cloud environment. Now, from a provider perspective, it is important to know, and also from a customer perspective, so no matter what side of the house you're on, it is important to understand how the provider provides this capability of having customers share resources and not get interfered with. So basically, we have a cloud catalog, an orchestration and automation phase, and virtualization and infrastructure components. So infrastructure components is everything from the storage to the networking to the data services to account management, etc. Then we have virtualization. So this is our virtualization layer. Could be our Zen, whatever the hypervisor is that's being used by the cloud provider. And then orchestration and automation. So the cloud provider certainly doesn't want to be answering the phone or emails, getting requests to deploy a VM for a customer. This is all handled through automation and orchestration. Now, the cloud catalog. So the cloud catalog is what the customer would go review, for example, and basically select what they want to deploy and be able to pay for that as well. So that's really the four main parts to really how the provider provides multi-tenancy. So as far as a test tip, pretty straightforward again. Resource pooling is multi-tenancy. And then when it comes to virtualization, this is really the enabler for resource pooling and multi-tenancy. That's the end of this lesson. Let's move on. Resiliency and dependability. Now, it's important to understand what resiliency is and how that plays into dependability. Now, when it comes to dependency, resiliency, also known as resilience, basically we want to first understand dependability. So dependability is really described as more or less the trustworthiness of a computing system. So in this case, the cloud. And again, this is more of the official definition. So redundancy basically is really duplicating effectively components so that if one set of components or one component goes down, we still have other components to use. So for example, like in the world of disk storage, we have RAID, for example. That's a perfect example of redundancy. Resilience. So what is resilience now? Resilience is the system's ability to basically recover if there is a fault. So for example, if you lose one disk and you're in a RAID 5 situation, you should be okay. If you lose 3, then that might be a problem. But with that said, just be aware that resilience is really the ability for a system, or in the case of the cloud, for the cloud service to be available. So what are some of the characteristics of resiliency? IT resources can be configured to meet this. It's really up to the provider to have the resources in place so you could do it, but it's also up to the consumer most of the time. Now, with cloud computing, resiliency refers to typically redundant resources, of course, and typically they could be in the same location or they could be in another region or even a zone. Now, it's up to the consumer, of course, to make their systems redundant. For example, I want to say about 3 years ago, probably 2018 or 17, maybe it was a little bit earlier, but right around there, it was a few years ago, Amazon S3 had a big outage in Northern Virginia. Now, pretty much if you're a customer on AWS and you had your storage on S3 in Northern Virginia, you were down for about 8 hours. Now, you weren't down for 8 hours if you had redundancy and you followed AWS's best practices to have redundancy so that your storage would still be available in another region. So basically, again, it's up to the customer to build this in most of the time. Now, when it comes to resilient computing, this is a form that basically provides failover. So if, for example, there is a service that goes down, or let's just say DNS, a simple example. So for example, if we're trying to get to the DNS server, we typically have at least 2 DNS resolvers typically programmed in our systems, so that if one is down, we could go to the other one. So basically, we want to have redundancy. And then, what about GCP? What do we have in GCP that provides resiliency? GCP has a wealth of options, and a lot of this does depend, though, on the services that you use and how you use them. But generally, you could pretty much do the same thing as you would do in GCP with any provider as well. But basically, regions and zones, so having multiple regions and zones. Redundant hardware, for example, if you're going to replicate, you want to, of course, have the right structure in place. Load balancing is a great example. So for example, if you have server A and server B, you might have one server that might be overloaded or goes down. You can route to that other server pretty easily with load balancing. It will handle that for you automatically. High available services. So if you use the right services in Google Cloud, for example, like DNS, global load balancing, etc., there's redundancy built into those services. Now, instance groups. Now, when it comes to instance groups, again, this is a little bit of ahead of where we're at in the course, but just to mention, an instance group very simply is basically going to be a group of instances. Now, instances meaning what? Virtual machine instances that we spun up, basically. And we're going to group them together so that we have maintenance and we bring them up and bring them down at the same time. They're managed the same way effectively. So that's an instance group. Auto scaling, health checks, these are just some of the other things we could do as well to provide resiliency. As far as the test tip, again, just understand what resiliency is. Don't confuse it with redundancy or replication or anything. But basically, it's the result of a highly available service or services that have redundant components that provide for the capacity to recover if needed during like an outage or availability issue. That's all that I had for this lesson. Let's move on. Replication. Let's talk about replication and why it's important to understand for cloud computing. Basically, replication is effectively taking a copy of data from point A and replicating it to point B. Now, replicating being what? Basically copying. Now, replication is, of course, going to provide us protection in case there's an outage at like a primary site or a primary region in a cloud, for example. But basically, in the cloud, we typically have regional and zonal replication. And because of that, we need to understand, of course, some of the intricacies of each of the cloud providers. But for this exam, we don't have to really worry about that. We'll talk about zones and regions in the next section of the course. But just be aware of replication, what it is. It's basically copying data from point A to point B. Now, when it comes to replicating data, for example, in this graphic from Google Cloud, we're basically taking data from looks like one region here and replicating it to another zone. So basically this is in one region. Now, just to be clear, in the world of cloud computing, the vendors call a region and a zone typically a little different, but they're similar. So for example, I'll just give you an example. In Google Cloud, we have regions and zones. In Amazon Web Services, they have, for example, availability zones and then regions. So that's, again, terminology is really the same. It's just that maybe it's just a little bit different as far as how they name it. It's the same concept, same principle, really the same thing. So with that said, we're taking data from point A and sending it over to point B. Now, basically, if we're going from one zone to another, that's basically like 2 feet away or 200 feet away when we're talking about cloud computing. Now, it could also be farther. It depends on the cloud provider. Now, if there's different regions, then it would be much farther away, much different levels of protection, for example. But again, for this exam, we don't really need to focus too much on that. I do want to make sure that you're aware of what it is and why it's important. We're going to replicate basically our data from one point to another. And in the cloud, we support typically zones and regions. Now also too, replication doesn't have to be just between the same provider. We could replicate data from on-prem to Google Cloud as well, or vice versa. So it's really up to us. So those are just some of the thoughts to be aware of. So what are the test tips? The main test tips is that replication provides for consistency of data during an outage. So for example, if we lose data over here, we still have it here. And it's available if we set things up right. So when it comes to replication in GCP, it's typically going to be regional or zonal replication. All that I had for this lesson, let's move on. Automation and orchestration. Now, these two terms are very important to really understand the difference between the two. Commonly, they can be confused, so I want to make sure that we don't confuse these. So basically, we could think of automation as taking what was typically a manual task and making it automated. So what does automated mean? Well, basically in a nutshell, we're just going to script something or code it so that it runs by itself. Pretty straightforward there. So basically it's going to be a single task or a function that'll be automated. Now, with orchestration though, things a little bit different, but similar. Let's talk about it. So orchestration is going to describe typically the automated management and make that so that it takes all these complex functions and basically brings them together. So we could think of orchestration as a way we're taking the automated tasks and creating a workflow and having that workflow execute through orchestration. So think of orchestration as basically no more than a way of basically taking multiple tasks and making sure that they get done in the right order. Very simply put. So let's sum up the difference. So automation refers to a single task, whereas orchestration arranges tasks to optimize that workflow. So once again, please remember that. Don't go into the exam confusing the differences between the two. Very easy to confuse automation and orchestration, especially when you're just learning some of this new subject area for you. So let's talk about some test tips. Now, as far as automation and orchestration, please don't confuse them. Once again, if you get a question around automation and orchestration, these are generally very straightforward questions. Try not to confuse automation and orchestration. So that's really the first tip. Make sure you memorize it. So let's sum this up. Orchestration takes a workflow basically of automated tasks, whereas automation is really what? Focus on a single task. For example, if I wanted to execute, for example, a build on a, let's say, virtual machine deployment, I want to deploy 100 VMs, what would I do? Well, basically, I want to automate basically that script of putting that basically virtual machine together. And I could do that in Google Cloud, for example, with infrastructure as code. But basically, for now, we'll get into the service more when we get to that point, but just be aware that I could automate that. And then when I take multiple tasks that I create and put them together into a workflow, that's where the orchestration comes in. So once again, orchestration, automation. Let's go ahead and move on to the next lesson. What is chargeback? Now, this is a common term we're going to run into in a lot of enterprises, especially in the world of cloud. One of the challenges when it comes to understanding our costs as an organization is to really understand who is using these resources, and for that matter, understand why as well. But also as part of that, we want to be able to ensure that resources are used in a manner that's appropriate and efficient for the enterprise. For example, we want to make sure that only the departments that use the services pay for the resources. So chargeback is really, again, a model that can be used to ensure that resources are paid for by the appropriate business units, and that if there is overspending, again, it's not going to affect another unit's, business unit's budget, let's say. So basically, chargeback is a way to point resource usage to a department, and also typically as part of chargeback, that department, that business unit, let's say, will need to have those amount of funds, for example, that was charged centrally to the organization, basically reimbursed so that there's a way to account for that usage. So the goal of using chargeback is to really improve cloud spending and provide responsibility to the people that use the model. It's an accounting model effectively. Now, as far as some of the characteristics, it is an accounting model. Basically, generally, in a lot of, I wouldn't say most, but a lot of organizations, This is implemented through basically a centralized procurement model. And basically, if we have a cost center, and a cost center is typically a business unit in a lot of cases, that business unit, that cost center, will be charged for those resources, and that goes against the budget for that organization. So basically, all the costs are zeroed out from a centralized point of view, and then basically chargeback, basically allows the consumers to see what they've been using and what they've been spending on. So we want to think of chargeback as really a model to use to mitigate expenses. So chargeback is a very common method for organizations to mitigate overspending. So again, that's our first test tip. Chargeback also provides visibility and accounting for resource spending. Once again, if we ensure that the appropriate organizations and users pay for what they use, they're going to be more likely to be responsible with that resource and not leave that VM on when it doesn't need to. And lastly, it is an accounting model. Let's go ahead and move on to the next lesson. CapEx and OpEx. Now, it's important to realize the difference between the two and understand where cloud really comes into play here. Now, in the world of procurement, we generally have basically funding provided through what is typically called a procurement exercise. It could be everything from RFPs over to just getting quotes, whatever that is. So if we're going to go ahead and buy, for example, a large purchase, that's typically going to require signatures and there's a lot of work to it. Now in the cloud though, because we're renting someone else's equipment basically, that is going to require more of a subscription approach. And because of that, we can generally use what's called OpEx funds. That's operational expenditures. Sort of like if you're going to go to training or if you're going to go and use a backup service such as Mozy. You're going to pay for that typically through OpEx funds. Now, when it comes to cloud, one of the things that has been going on is that we have a big shift from CapEx to OpEx financing. And basically, the cash flow model that's used basically in the world of IT is basically shifting more towards OpEx funding. And this is, again, really important to understand. So capital expenditures are investments that are made by the organization for long-term benefits. Well, because of the cloud in the last 10 years, there's been a massive shift of organizations that have really effectively stopped investing in their infrastructure. And this is important to realize. The cloud has really provided benefits to where just about everyone is an equal player, whether you're a large organization like General Electric or a small startup in someone's basement. So because of that, you can basically use your credit card and just pay for the resources as you need. Now, operational expenditures are basically ongoing costs that typically most business units have. Let's say you're a manager and you get so much every quarter in OpEx funding to pay for training for your people, to pay for parts that you may need, or to pay for subscriptions. Again, that's our OpEx funding. Now on the right side is a table there that sort of gives you an idea of mainly the difference and why it's important. Another thing too is really the tax benefits that I think a lot of organizations get. You go spend your money now and get it written off this year. Whereas if you go out and spend, $10 million on racks and gear and all that, network switches, then you have to amortize that over a long period generally. So that's another benefit of why companies are looking at OpEx. They can just write it off. Now, when it comes to cloud computing, again, there's a big shift from CapEx to OpEx. CapEx is really about what? It's about ownership of the assets. OpEx is really about paying for services, and that's really the main point. So we want to understand that the cloud is really shifting spending from CapEx to OpEx. the funding model for IT resources has really changed. Cloud is generally paid for basically like a subscription, generally using OpEx funding. Let's move on to the next lesson. ROI and TCO. These are going to be some acronyms you're going to hear a lot about, especially in the planning phases of cloud computing. So we really want to focus mainly on ROI in this specific lesson, but I will talk about TCO as well. Because from a comparative perspective, there's a lot of confusion. Oh, fuck, dude. ROI and TCO. Now, this is going to be, again, a section that we really want to understand, especially when we're getting ready to take the exam. So in this lesson here, it's more focused, again, on terms and what they mean and why they're important to really consider from mainly a planning perspective and assessment perspective. So we have return on investment. This is really more or less a measure of understanding the success, basically, of a project. Now, ROI from a terminology perspective really comes more or less from the business side of the house. And then I'll talk about how the term and the definition adapted more for the cloud. So basically, ROI is really an increase in the value of an investment over a period of time. So what does that really mean for the cloud? Well, let's just give you an example. Basically, over here, we have, let's say, an application running on-prem, and basically our return on investment basically is 0 or maybe 1%. It could be negative, just based on the way we look at it. And that's based on, let's just say, a revenue generating application that we might be reselling or selling to the business. On the other hand, that ROI could be 8% or higher, whatever it is. And then if we go to the cloud, we want to compare what that ROI could be in the cloud. Maybe it'll be 9%, maybe it'll be higher, maybe it'll be lower. So we have to compare apples to apples. Again, as grandma used to say, basically we have to look at, are we comparing this correctly to what we would have over here? So some of these numbers in the cloud will be harder to come up with just because we may not totally understand what our network traffic will be. We don't understand our data service usage, let's say. There could be a lot of factors. Now, when it comes to TCO, this is another term that you're going to run into. This is basically, very simply put, is basically adding up all the costs, basically, and that's our TCO. When it comes to the TCO, we want to be aware that this number can change significantly going from left to right. Now, left being from on-prem to the cloud being right. Now, generally, we want to always try to optimize our TCO. So, for example, if we're on the cloud and we need to consider, for example, and this is really true in the compute services area on any cloud platform, we may be using on-demand resources and we're always using them day to day. Maybe we could lower the cost of using that service, and therefore that cost of that one service can actually increase our return on investment. This is a big deal. So we have to look at it from that perspective. So basically, also too, when it comes to trying to optimize these expenditures, we need to look at all angles. One of the biggest costs is going to be compute, but when it comes to some of these measures like network bandwidth, it's pretty hard to estimate what that might be in a lot of these applications. Another thing could be the data storage resources. So, for example, we may want to use specific big data resources. Every cloud service charges differently for using these data services. Also, too, when we're accessing resources or pulling things out or dropping things in the cloud, that's charged differently. So an ROI calculation quantifies generally costs and the benefits over a specific project over a specific time frame. So in the world of IT, that's generally how we look at things. So ROI has both tangible and intangible components. So what exactly would be a tangible component when it comes to ROI? Real good question. So tangible would be anything from basically being able to measure something. So whatever we can measure directly, such as the number of compute hours used or the amount of view time on a web page. Those are tangible. Other things that are not tangible would be basically company image, or let's just say basically getting to market sooner, having to understand, does that actually bring in a benefit or not financially? Maybe getting to market will bring in a better benefit. Generally it does, but sometimes that could be hard to measure. But those intangible components, again, could be everything from user satisfaction to basically company image. And again, a lot of that is really dependent, on how you measure. Now, again, the concrete stuff we can measure is basically that bill that we get from the cloud. So that's easy to measure. Now, what is the goal? Basically, the goal of any project should be to return a solid return on investment and a low total cost of ownership. In other words, lower cost, a higher return. Pretty straightforward. Now, what are some of the benefits? And also, too, what are some of the ROI measurements? So we want to talk about the benefits and also some of the measurements at the same time. So we should be able to understand that if we reduce or eliminate licensing, that could be a good thing. Agility, are we able to respond quicker? Operational expenses, always a big deal. Are we able to share resources between different business units? Are we able to reduce the costs and also provide a better service? Reducing a lot of our environmental costs. So for example, if we migrate, let's say, these racks of service from a data center, that's going to save us so much in electricity. That could also save us environmental, such as cooling. Can also reduce our space used as well if we can reduce that on our lease or whatever we're doing with that property. So a lot of that can matter if you're leasing or if you own the property. Also too, if we're able to reduce IT assets, this is a big deal because a lot of those support contracts that can cost you tens of thousands a year or even a month if you look at the large data center. This is a lot of money. So if we're able to reduce all that, that's a big deal. Now, as far as measuring cloud ROI, these are just some of the things we can measure. So if we can measure usage, optimization, compliance, capacity improvement, reduction in labor costs, faster time to market. Again, if we get to market a month earlier, even a month earlier in a hyper-competitive world, this can be the difference between your executives making a big bonus at the end of the year and you having a job, or maybe not. Who really knows? It could be that extreme. So with that said, these are just some of the measurable benefits. Now, what about a formula? How do we figure all this out? Now, traditionally, the ROI equaled the net benefits and the total cost. That's the official sort of number that was used in the financial world. Now, generally, another formula that would be used would be the gain from the investment minus the investment. So the gain could be measured any number of ways, and then whatever that investment is. So basically, if we brought in $14,000 and it cost us $10,000, that would be our return on investment. So with cloud computing, generally what we want to do, though, it's not as simple as, flopping down $1 million in the stock market and that's, the ROI we get on a profit, right? It's a little different. So with cloud computing, we want to use what's called key performance indicators. These are called KPIs. Now, We don't have to worry about all these KPIs. Or, again, for the exam, you're not tested so much on that, but we just want to be aware that KPIs could be anything from capacity utilization to how many hours the application's used. Could also be, for example, how that application is used by individual business units. Also too, another KPI that can come up could be uptime. Basically, are we able to maintain a better quality service for the users? User satisfaction. These are anything like that could be a KPI. Also too, when it comes to some of the typical compute KPIs, that could be everything from the number of reads and writes down to basically something simple like uptime, right? So with that said, those are just some of the things that we could measure. All right, now, what about some test tips? The main thing that we want to grab out of this specific lesson is really understand that ROI is used to measure the success of a potential or ongoing project. Now, when I say project, generally migrating even something like SQL from on-prem to the cloud is a project. So we want to, understand how that really works out. So to do that, we want to measure what's called the ROI, right? So basically, if it costed this and now it's costing this, here's our return here, here's our return now in the cloud. What is that? Is that better or is it worse? The goal should always be to obtain a solid return on investment and a low total cost of ownership. In other words, we always want to reduce the costs, but get a better return, right? Pretty straightforward. Business 101. Let's go ahead and move on to the next lesson. Section summary. Let's now go ahead and review what we covered around the main points before we go to the review questions in the next lesson. We know that in cloud computing that there was a lot of different organizations involved that provided standards and also guidance around cloud. The most eminent is really NIST. And NIST provided basically to the community as well as the governments basically a cloud model. This cloud model provided 5 essential characteristics, 3 service models, and 4 deployment models. We know that cloud computing has many significant business benefits. Some of those benefits would be low-cost services, agility and elasticity, open and flexible capabilities, and secure as well. Now, the 5 characteristics are on-demand, self-service, broad network access, resource pooling, and also rapid elasticity and measured service. We learned that chargeback helps with managing cloud spending for organizations. We know that GCP is a public cloud. We also learned that hybrid cloud is when we combine our on-premises apps, for example, with Google Cloud. There are 3 service models: infrastructure as a service, platform as a service, software as a service as well. We also learned, of course, with the different service models that with infrastructure as a service, we have more flexibility in how we deploy and better control of what we deploy. With software as a service, for example, it's mainly just setting up software and logging in and deploying users, for example. So there's less flexibility. We learned that there's 4 deployment models: private, public, hybrid, and community. We also learned too that with hybrid, that's typically, again, going to be combining on-prem with a cloud platform. We also learned that private is going to provide better security, of course, better compliance support, and also, as well, possibly better performance. And public clouds are what? GCP, AWS, etc. Lastly, vendor lock-in. We want to prevent vendor lock-in, and the way that we would do that typically is by using open standards. For example, Open API is a great example of that. With that said, let's move on to the next lesson. Few questions. Let's go ahead now and test our knowledge and see how much we've retained during this section. Now, the first question is going to be referring to the NIST 5 essential characteristics. The first question basically states, which of the following NIST 5 essential cloud characteristics would be used for enabling the sharing of resources between cloud tenants? So this one here is select one. So if we're sharing resources, what does that sound like? Well, that would be resource pooling. Next question. Which of the following would be considered benefits of using a cloud service such as Google Cloud? So the key here again is Google Cloud is what? It's a public cloud. So because of that, we would have public cloud benefits. So the benefits would be as follows. Use of low-cost services, open and flexible service, and secure services enabled. Now, the two answers that are incorrect would be support open APIs for every service. Well, open APIs is not supported for every service. And again, this is true with any cloud provider. And services are fully managed. So some services are fully managed, but not all. Now, which of the following 5 essential cloud characteristics would provide the ability to receive proper billing for your cloud services? So this question here is referring to what? Measured service. The next question. You are currently considering an application that will be hosted on Google Cloud. You want to ensure that if there is an issue, that the application will be tolerant of any outages. So basically, what is this referring to? Well, this one here is a little bit trickier. You got to read into the question. So dependability. Well, that sounds like a good answer, right? The system being dependable. Redundancy, resiliency, or orchestration. So the answer would be resiliency. Remember, resiliency is a result of what? It's a result of having redundancy and also providing basically dependable systems. So that's all that I had for this lesson. Let's go ahead and move on to the next section.